10 minutes for the two sections. So the next one is 3.4. Another truth table. So truth tables, but this time for the next two connectives for conditional and biconditional. Conditional means if then, biconditional, if and only if. So if then, this is if and only if. And sometimes we use the short term like IFF. Okay, so for the truth table of the if then, and at least you're going to have the two simple statements when you form the truth table. So statement P, statement Q, we build the table and always have like 4 combinations for the two simple statements. So this is P, this is Q. And then I'm going to form another one for the biconditional statement. This is P, then Q. This P and if and only if Q. So this one, if then. This is if and only if. How about I write this way? It's called if P, then Q. And this gonna be P, if and only if Q. Okay, put the 4 combinations as before, the true, true, false, false, and then the second column gonna be true, false, true, false, true, true, false, false, true, false, true, false. For the if then, this is slightly different than the way that you can recognize the table of the connectives like negation and or in the previous section. So for the if then, only the case that the P is true, but the Q is false. Okay. And by the way, the if P then Q, P is called the antecedent and the Q is called the consequence. Or you can call cause effect, you know, P happens first and Q happens later as a consequence of the event P that occurs. So if P is true, if something happened before is true, but the result doesn't come out as a true, so that case is not valid, or that case is going to be a false statement, which is the second case here. Antecedent true, but the consequent false. This gonna return the false statement. Otherwise, it's gonna be true. So wrap up, T then F equals F, otherwise gonna be true. Okay, for if and only if, as long as the left and the right side of the two-head arrow have exactly the same truth value, the result gonna be true. So for the table, we have 2 cases that both of them have the same truth value. Both of them true, the result gonna be true. Both of them false, the result gonna be true. They have to match. If they don't match, the result gonna be false. So gonna be T if and only if T equals T, and F if and only if F equals T. Otherwise, you get the false. So basically, you can say like must be the same. Otherwise, false. Okay, so this is a quick the summary for constructing the truth table for the conditional and biconditional. Let's pick up one example. See the next one, the one that has both if then and all of them. Okay, we're gonna construct the truth table for P then Q quantity if and only if quantity not P or Q. Okay, overall you have two simple statements PQ. You're gonna have 4 rows or 4 combinations, but how many columns? Let's analyze like the last time that we did. Ask yourself, let me put the list here. The given gonna be PQ that you start with the 4 combination. You're gonna need one column for the P then Q. P then Q. That's on the left side of the two-head arrow. And you're gonna need not P. You're gonna need the connective OR of the not P and Q. And then you're gonna need the last one, which is the compound statement that connect the P then Q and not P or Q. So how many columns you're gonna need? Need 1, 2, 3, 4. 4 extra columns. Okay. So starting with the PQ column, like by default, we have 4 combinations. And the truth value, true, true, false, false, true, false, true, false. And then we're gonna build the next column, which is the column for the P then Q. P then Q, that's one of them. And the next column gonna be not P. Another column for not P. And the next column gonna be not P, not P or Q. And the last column gonna be the final answer, which is P then Q, if and only if not P or Q. All right, now put them together one at a time. For if then only the case is true then false, result is false. That is the second row here, true then false. This is the false, otherwise you're gonna get true. Negation of the P is opposite of the column P. So we can write the opposite truth value as false, false, true, true. And next gonna be not P or Q. It looks like not P and Q, they are further apart. So I'm gonna pretend like I have like slightly small column here just for my convenience. So I'm gonna put true, false, true. Let me make it wider. It's kind of squeezed in there. Gonna make a small one here with the column for the Q. And just copy what you see in the queue. So true, false, true, false. And we're gonna connect with the OR. We call the OR. Both of them must be false to return false. Otherwise, it's gonna be true. So only the second column that see the both false. Otherwise, true, true, true. Okay. And then the last one, what you have to do is to look for the truth value of P then Q and the truth value of not P or Q. Connect with the if and only if. So I can make a template here. So the first one gonna be T if and only if T, F if and only if F, T if and only if T, T if and only if T, and then my result for each case by the the way that we construct the table for or the truth value of the if and only if, both of them must be the same to return the true value. And for this problem, the first row, T, if and only if T, they look the same, so 2. The second one, they look the same as well, even though both of them false, gonna be true. And then another true, another true. The problem returns all true for all cases. I mean, true for all cases. So this case is a case of the tautology. Okay, so we are done, and the result is the result from the last column, which is this one. So this is a result.